Hello everyone, and thanks for tuning in. In this video I'll show you how to deal with fractional riddles, that is math riddles containing calculating with a fraction of a fraction. They are not necessarily intuitive, and in this video I'll show you what works and most importantly what doesn't and why. So let's take a look at this riddle specimen here. Very typical. June, that's not the name of a month. It could be Jimmy, Julio, or whatever, some name of a person, is spending her savings. She spent 1/5 of her money on Monday. On Tuesday, she spent 1/3 of the money she had left from Monday over. And on Wednesday, she spent half of what remained after Tuesday's purchases. After all this shopping, she still has $60 remaining. How much money did she originally have? So this is a fraction of a fraction of a fraction, and we have a remainder. So this is the only solid number given. Those are three are fractions. So problem number one, fractional problems do not reverse by the same fraction. So using half and third and fifth in reverse order doesn't help a whole lot. Take a look at this example here. Half a dollar is 50 cents. So there's your fraction in it. So far so good. Now, when $1 is increased by half of it, by that 50 cents, it's $1.50. Now if you're trying to use this half, this fraction, then you're not going back to $1 because half of $1.50 is 75 cents. Not 50 cents. You see, $1.50 decreased by the half of it is 75 cents. It's not 50 cents. You're not, by using the same fraction and reversing the direction of the calculation, you're not getting back to the original 50 cents that you started with. You are now at 75 cents. The reason for this is nothing wrong with the fractions. There's nothing wrong with the amounts. The reason for it is because reversing math problems involves changing the base of the calculation. In this one, the base, it's an implicit base, is $1, and in this one the base is $1.50. Completely different bases, and logic dictates that it cannot, doing the same math to the same base will doing the same math to a different base will not result in the same amount. The same works with grammar, okay? So consider this sentence here. Changing the subject in grammar is a no-no, because changing the subject is like changing the base of the calculation. This would be a base, and this would be a base here, okay? So changing the base is like changing the subject in grammar. Here's the sample sentence. Jimmy walked up to the house, got greeted by a dog, then he fell down with a heat stroke. Last word here reads foaming at the mouth. So in this sentence, it's unclear whether the he refers back to the dog or Jimmy. It could be either. It's unclear. It could be the dog having a heat stroke or Jimmy. If the sentence starts with Jimmy and the dog got a heat stroke, that's changing the subject very subtly. Okay, so changing the subject is similar to changing the base in a calculation. That's a no-no. That's why reversing percentage calculations or fractional problems don't work because the bases are going to be different. So let's try to reason it out, and let's see what doesn't work. This looks like it works. Let's take 60. Half of 60 is going to be the Wednesday amount. Half of 60 is 30, obviously. And 60 plus 30 is an easy number. Hey, it's 90. I want to point out that if you, instead of adding, you can also multiply. If you multiply 60 by 150%, you're gonna get to 90, because 60 increased here, addition has been replaced here by multiplication. So that's an important little side step. And then work on backwards in reverse direction with the 90. 90, let's increase 90 by a third, because that gives us the Tuesday amount. A third of 90 is conveniently 30. 90 plus 30 is 120. We have a nice whole number, easy to work with. And it looks very straightforward, and because it's whole numbers, it looks like we're onto something, but we're not. So 120 then is increased by a fifth of it, again, a fifth of 120, another whole number. We must be doing something right. No, we're not really. But 120 plus 24 is 144. We have a solution. Let's, however, check our work. And this is where 144 will not work out. So this is calculation done backwards, 60 being assumed as the base, and using the same percentages as in the original practice problem, just in reverse order: the half, the third, the fifth. So let's check our work. So 144 times 4 over 5. Okay, what happened to the 4 over 5? Why is it replacing the 1 over 5? It is replacing it because this is what remained after 1/5 was spent. Okay, so instead of doing multiplying by 1 over 5 or calculating the fifth of 144, which is 20 something dollars, instead it's just in one step. It's $115.20, and this 20 cents might alarm you. It's not a whole number. It's not a problem necessarily in math classes, but it is usually an indication that this 20 might fracture further down into some infinite decimal number or something like that. So using this number and multiplying it by 2/3, again 2/3 because 1/3 was spent and 2/3 was left over, calculates the leftover money here. And taking this 76.80 over here to the last problem, you are left with $38.40 instead of $60. So obviously starting with 144 does not work. And again, it doesn't work because this approach starts with 60 and uses the same fractions as in the original problem. So what works is algebra, as well as one other thing that works is guess and check. So let me show you here, guess and check. So in Excel, I wrote up the same numbers, just slightly differently in a spreadsheet. So how this looks like horizontally, there's the Monday amount, and 4/5 of it remains, and that's going to be here the Tuesday amount there. And then the Tuesday amount is taken, 1/3 of it is spent, and 2/3 of it remains, and that's going to create the Wednesday amount. And this Wednesday amount is then taken in the morning, and half of it is spent, and there's 60 left over. So that's how it works. And if I put it into instead of reading horizontally here like this, I can maybe arrange the numbers differently here. I'll explain what all of these zeros are in a sec. So let's start with 144 because that's what the calculation here has given us. This 144 was, or this one here, it's slightly out of view there, 144. Let's take it to the Excel spreadsheet, and if we plug in not the same percentages, these are slightly different now. I'm changing the numbers a little bit because the formula here shows it's this cell, these are cells, cell A10 multiplied by 4 over 5, fractions are written like that, and multiplication is written like that in Excel. So this is cell A10 times 4 over 5 because 4/5 of the starter amount remains, goes into that cell, and alas, it is $115.20, same as calculated here. And switching back to Excel, in this cell here, the formula is cell A11, so the previous cell, times 2 over 3, because 2/3 of this amount remains. And in the last one, the formula is half of this cell. So the same fractions, 1/2, not the same fraction, sorry, this seems like the same fraction, but half of the remaining amount of a half is a half, okay? And here the fraction was again 2/3, because that's the remaining amount, and here the remaining is generated by 4 over 5. So even you can see the amount is calculated. If I put in 144, it's gonna be 38.40, exactly as it's shown here. We ended up with here $38.40. So what I've done here with guess and check is I copied the formulas just horizontally, this one sideways like so. So this formula here is the same as this one, and this formula here embedded. We just have to put in different numbers. So what we want to see on the bottom here is 60. So how do we do that? We can, obviously this is $38.40, so we need more than $144 to start with. So how about $150? Okay, if we start with $150, we're gonna end up with $40. Let's try a little more, $200. How's that looking? Nice, we're going up, we're getting closer to 60. All right, how about $300? What are we getting at the end of it? $80. Okay, so 300 is overshot. About 250. Okay, we're getting close to $60 here, and so it's between $200 and $250, and you can continue with guess and check. Eventually you're gonna get to 60, but so this is one approach that also works. I have here algebra, that also works. So consider this here. The Tuesday amount is generated by starting with the Monday amount, and this middle dot or center dot here is multiplication. So, and multiplying it by 4/5 of it, because 1/5 is spent, so it's subtracted, so what's left is 4/5 of it again. So that makes the Tuesday amount. The Tuesday amount then can be plugged in here. Everything that's printed here can be plugged in here into the formula, and a Tuesday amount gets 1/3 of it spent, 2/3 of it remains, and that creates the Wednesday amount. And then the Wednesday amount gets halved, and that equals to the remainder of 60. So how these can be rolled up is that this W can be replaced by all of this, and that's what's written on this line here. And this Tuesday amount can be replaced by everything that's here. So this is how they all look like. The Monday amount is what we're looking for, or M, is calculated by multiplying these three fractions, and the calculation should equal 60. So typical fraction multiplication standard procedure: multiply the numerators, multiply the denominators. 4 times 2 is 8, times 1 is 8, 5 times 3 is 15, times 2 is 30. That's what you see on the next, 8 over 30. Multiply both sides of the equation by 30 and divide both sides of the equation by 8. There's your answer, 225. Let's check our work in Excel and plug in 225 here, hit enter, and it works with the same formulas of the calculation here, working with either 4/5, or you can see up here, if you can read it, the formula is slightly different, but I can change it to times 4 over 5, same numbers. Okay, so whether it's subtract and use the original fraction, or just simply multiply by the remaining fraction, this works. So with guess and check, you could get 225 as well as you can get it elegantly or fast with algebra. So let's check our work, see how this 225 works. 225 lessened by 1/5 of it is 180. 180 lessened by 1/3 of it is 120, and half of 120 is 60. So besides algebra and guess and check in Excel, there is one other thing that works. It is logic and reciprocals of fractions. See, if you ended up with $60 and that was half, after spending half of your money, you have $60 in your hand, you must have started with $120. How this looks like with reciprocals is this. The words here is your $60, and having spent half of your money, so you must have started with twice as much money as what you have in your hand. So twice as much is replaced here by 2/1 as a fraction. The same logic applies, the same reciprocal applies here. This 120 then is increased by the reciprocal of 2/3. 2/3 calculated the remaining amount, and the reciprocal of the remaining calculates the amount that you must have had in your hand to begin with. And likewise, another reciprocal here helps with calculating the original amount. So this approach, logic, as what I call, also works. So that's basically three approaches how you can deal with fractional problems. So you need either algebra of the original amounts, making equations like these ones again, and those are not the original amounts, those are the opposites of the original amount, something like that. Or you can work with reciprocals if you like reciprocals, like so. Or you can do guess and check with the formulas, and of course you can also do this in Excel, that you start with 60, you plug your reciprocals in. Here is this cell A25 multiplied by the reciprocal of that cell content. This one also is a reciprocal, is 3/2, and is the last one 5/4. So if you start with just 60, once you write up your formulas and you plug 60 in here, you could plug in another number, whatever, it's just going to recalculate depending on whatever fraction problem. If you have, after spending everything, on Wednesday you have $100 in your hand, bam, you must have started with $375 if the same amounts were spent, the same proportion, 1/5, 1/3, and half. If not, you can just modify the formulas in Excel and be done in seconds. So those are some approaches that work. That's how you deal with fractional problems. They need a little bit of thinking, but they can be done.